Good afternoon, everybody, and good morning in the West Coast area. And if anyone is joining from overseas, greetings to all of you. Welcome to the 22nd technical webinar of AABEA, which stands for American Association of Bangladeshi Engineers and Architects. We try to hold this webinar, technical webinar, once a month. But there is no limit. We can make it more. Sometimes we don't make every month because of the lack of speakers, etc. So we are fortunate today to have Mr. Russell Harrison, a board member of IEEE. And before we give his formal introduction, I would like to recognize all the participants here today. On my screen, so I'll go from top to bottom, left to right, is on top left is Dr. Gulshan Ara. Dr. Ara, would you say something about yourself, please?
Yes, hi everyone. It's good to see a panel of very intelligent people, very bright people. You know, my interest, I had a PhD in physics, but my current interest is in climate control, and then particularly carbon capture technology. And then using that carbon, you can really make carbon fiber. And then can we make carbon, use carbon to make chips, computer chips? So that would be this is my main interest, and that would be my question sometime during the talk. So thank you so much for giving me the opportunity.
Okay, next we have Mohammed Iqbal from Los Angeles. Iqbal, please say a few words about yourself.
Hi, my name is Mohammed Iqbal, as you said, and I work for U.S. Navy in the electronics warfare. My background is Bachelor in Electronics Engineering as well as MBA. I have been focused in chip industry for a long time. My goal is someday, and which I tried a couple of times, I failed, but still I did not give up. Someday a small scale, some chip development factory in Bangladesh. That's my goal. How I'm gonna do it, how I'm be able to do that, that's the question that I look for always. So anyway, I had a meeting with the Minister of ICT Minister in Bangladesh. They just want to give a land, but they don't want to give the equipment, which is the most expensive. So I kind of gave up. That didn't happen. It just 2018, 2020, I tried, but then last 3 years, I'm kind of don't have any. So my goal is very soon, I probably be retiring from US Navy, then I'll be focusing on this. So any information I collect will be always worth of looking into that. Just one quick question that I have, that what Dr. Gulshanara said, the carbon-based, which I learned a long time ago, carbon has a fantastic IV carbon. Carbon can be used to make chip too. So that is my knowledge, but how it can be implied, that's another good thing to discuss. Okay,
let's take it over during the Q&A, maybe it will come up. Next, I have Dr. Sufyan Khandekar. Sufyan bhai, will you please say a few words? You're muted. Unmute, please. You still muted. You can unmute and keep yourself unmuted. So let's go to Ruhul, which is our DC chapter secretary. Please, Ruhul.
Yes, hi. Thank you, Dr. Anis Rahman. Thank you for hosting this very informative webinar. My name is Ruhul Chaudhary. I'm the current secretary for the AABEA DC chapter. And I'm currently working at USDA as an electrical engineering branch chief, where I work for an agency that helps provide broadband service in rural America. And I'm really happy to have Mr. Russell Harrison provide this webinar. We've met before. I don't know if you remember Mr. Harrison at the AABEA convention in Maryland last year, and really appreciate you and volunteering for AABEA. It was really really pleasant to meet you, and really honored to have you today at the webinar. Thank you.
It's good to see you again.
Next, Professor Farooq Siddiqui from Swarthmore College in Pennsylvania. Farooq bhai, please unmute yourself.
Hi, this is Farooq Siddiqui. I'm a retired professor of civil engineering. I taught at Swarthmore College for close to 40 years. Prior to that, I was a lecturer at the Bangladesh University of Engineering and Technology. So my interest, this is way outside my realm, but my interest is similar to what Dr. Gulshan Ara is. Since as I'm a civil engineer and concrete is one of the most ubiquitous construction material that is used all over, and its carbon footprint is obviously quite large. And so however, concrete, when concrete cures, it captures carbon dioxide from the air. So I am interested in the manufacture of cementitious materials, whose carbon footprint is smaller, number one, and also in how to use existing concrete that comes as waste material once pavements are destroyed or crushed and just sent to landfills. Also of all the old concrete buildings that will eventually be destroyed, and we will have to find out ways to reuse them. So that's my interest.
Thank you, Farooq bhai. Let's go through the talk now. I see Sufyan bhai is unmuted. So Sufyan bhai, please.
Thank you, Anis. I'm very much associated with AABEA, American Association of Bangladeshi Engineers and Architects, and I have been involved in many seminars. Professionally, I'm a civil engineer, well known more as a water resources engineer on infrastructure. My first 29 years was on the design and construction of power plants. The remaining 21 is the flood resiliency and climate change. So my interest will be on the carbon capture, climate change on this presentation. Hopefully I'll get something out of this presentation. Thank you.
Okay, and last but not least, Asif, please go ahead now.
Hey, hello everyone. Hi again. This is Asif Salahuddin. I'm from Michigan, calling from Detroit area. So I work for General Motors. Before joining the auto industry, I was in grad school. I landed in University of South Carolina, and then did my PhD from Georgia Tech, and then I came to Michigan and joined what is called Stellantis now, which was previously FCA or even Chrysler. And my interest on this side, like now, I'm a mechanical engineer, but my connection with AABEA is I'm currently the organizational secretary in the Michigan chapter. And we just yesterday hold a science camp for the kids. It was great. So always think that with the resources what AABEA is trying to achieve, and bringing in speakers like Russell Harrison, welcome for giving your time. And so on that's my connection with AABEA. And from the automotive industry side, I'm in the IT department now in General Motors, trying to develop tools for physics like computational fluid dynamics, CAE, and we provide in-house tools for the company. And that's where we use a lot of high performance computing, and sometimes based on the need, we want to strengthen our HPC resource. And from the automotive side, maybe one of my interests would be, since there is a chip shortage on different electronics and all the autonomous vehicles that coming, and since Russell may be more involved in the government regulations, and what as a private organization like a big OEM, how government sees these requirements, the chip or maybe the regulations of chips, where to get this from internationally and internally, and maybe he can give some insights on those as well. Yeah, that would be my interest.
Wonderful. Let us now, thank you, Asif. Let us now welcome Mr. Russell Harrison. We have the extreme pleasure to have him to speak here today on AABEA technical webinar. Russell Harrison is the managing director of the IEEE-USA and director of government relations, which focuses on the unique needs of IEEE members in the United States. Over his 20-year career with IEEE-USA, Russ has represented IEEE members to the American government on dozens of policy issues, including autonomous vehicles, digital privacy, artificial intelligence, federal research funding, export control, and immigration. He has spoken at over 300 local, national, and international events about public policy and the need for technology professionals to interact with their elected leaders. Prior to IEEE-USA, Russ represented recycling facilities and the steel industry on Capitol Hill. He has a master's in public management from the University of Maryland and a BA in the political science from Allegheny College, which is in Pennsylvania. So without further ado, again, it's my honor and great privilege to welcome Russ Harrison.
Thank you, Anis. It's great to be here, and it's good to connect with AABEA again. I enjoyed joining you all last year at your annual meeting, and this is a good next step. So what we're going to talk about today is the CHIPS Act and what the government is doing with it, what they hope to accomplish with it, and where we see programs popping up. And I'm going to focus mostly on the non-CHIPS part of the CHIPS Act, which I'll explain in a minute. But the bill is enormous. It is a huge amount of money. It has got some ancillary legislation associated with it as well. So we're going to focus on just a piece of the bill, but I can then answer questions as best I can about any other part of the bill that you're curious about. All right, so start with IEEE-USA Public Policy Department, which is where I've worked for the past 20 years. We are the eyes, ears, and voice of America's technology community. Want to emphasize that IEEE-USA represents all IEEE members in the United States, not all American IEEE members, an important distinction that we take seriously. But we're in Washington, D.C. Our office is right downtown, not too far from the White House. And we work directly with the U.S. government, the Congress, and the administration to make sure they know what you and other technology professionals in the U.S. are worried about and what the government should do to help. Not going to go into a lot of detail on what the CHIPS Act is, kind of in a big picture. You all kind of know. CHIPS and Science Act was signed into law almost a year ago, a little less than a year, and it is a massive investment in industrial policy, technology, and the American technology workforce. This is one of those once in a decade, maybe more than that, pieces of legislation that, in theory, should dramatically change the United States and, in fact, the entire globe. So quickly, what is it? The kind of top line information, the headline here, excuse me as I move you guys pictures, you're getting in my way. There we go. 52 billion, maybe 56, depending on the account, in direct and indirect subsidies of chip manufacturing in the United States. That is money that is going directly from the government to companies. It takes the form of tax breaks, financial assistance, direct subsidies, all sorts of things designed to encourage companies to manufacture computer chips in the United States, which they are apparently doing. The money is flowing, grants are going out the door. The government has been very aggressive in getting this money into people's hands fast. And they are claiming that we have 4 new fabs which will be built in the United States because of the CHIPS Act. Now, one of those is the Intel facility in Ohio that was announced a year before the CHIPS Act passed. So Intel is getting money to build there, but they were already planning on doing it. But the bottom line is it is generating, the bill is shifting company priorities and shifting company focus from outside the United States inside the United States, which was the goal. So that's kind of the top line stuff. I want to talk to you about the bottom line stuff. Technically, the bill is called the CHIPS and Science Act. And these were actually two pieces of legislation in Congress that got smooshed together before they passed. And they complement each other, but they are different. So focusing on the Science Act, this is a research and innovation bill that isn't actually targeted specifically at chips. It can be, but it's actually broader than that. There's a section in there on STEM education, on NASA, supply chain resilience. There's some things in there about workforce development. But the big thing, I think, long term in the Science Act, and for those of you listening, can you mute yourself for the remainder of the presentation, and then we'll open everything up for questions. So the CHIPS and Science Act created the TIP Directorate within the National Science Foundation. That's Technology, Innovation, and Partnerships. The TIP Directorate is unique for a couple reasons. One, unlike other parts of NSF, it is not focused on broad research, basic research, very speculative research. Instead, it is targeted at 10 specific technologies, which are listed there, or 10 specific research areas, although they're all technically technology when you get down to it. And the TIP Directorate is tasked with doing research in these areas that will have societal benefit. And what Congress meant by that is jobs. This research is not supposed to be speculative. It is not really supposed to be basic research. It's supposed to be more applied. Still kind of long term, so some of it's basic. But the idea here is these are investments in these technologies. And if you look at those technologies, they are all engineering technologies. Biotech has some engineering, some bio. Disaster prevention is code. Disaster prevention means climate change and making the United States more resilient. So infrastructure, fixing the electrical grid, that was in another bill as well. So even the disaster prevention category here is really focused at technology. Now, there are some big implications from this bill. First of all, this represents a very substantial pro-technology shift in federal research policy. Up until now, the federal government has been, particularly the National Science Foundation, DoD, Defense Department's a little different, but the NSF was agnostic when it came to research. They got a big bucket of money every year from Congress, and they kind of spread it out evenly among all the sciences, including the social sciences. Well, the CHIPS Act doesn't do that. The CHIPS Act says technology research is what we need to focus on. This is where we need to put resources, and the other stuff is good. We should still keep doing it, but we definitely have to do this. And so it is a clear statement by the US government that while all research is important, it's not as important as technology, which is very exciting. The CHIPS Act also has very broad STEM workforce investments. This was actually a very big debate on Capitol Hill. If you're going to train the American workforce to be more innovative, where do you put your money? And some people said, well, we need to invest in graduate research, graduate students, postdocs, professors. CHIPS Act said no. Ultimately, Congress said, no, this is about the entire workforce. K through 12, a little bit, but technical training, apprenticeships, certificate programs, community colleges, undergraduate and graduate students. The understanding is that this isn't about learning how to build chips. This is about actually manufacturing chips. And to actually run a fab, you need a great deal more than just some really good PhD engineers and physicists. You need people to work the clean room. You need people to build the thing. You need people to fix the machines. A lot more people, and the CHIPS Act said we're investing in all of it. Interestingly, and if this works, this could be quite a big deal. Congress also said this is not about Austin, Boston, and Silicon Valley. I mean, it is. They're going to get some money too. But this is about everywhere else. And Congress took a piece of the CHIPS Act and said this amount of money, this amount of research and incentive money, needs to be spent in states that don't get a lot of federal research grants. This is being run through the EPSCoR program at NSF. EPSCoR is dedicated to getting government research money to states that get a disproportionately small percentage of the research pot. There's about 24 states plus 3 territories in EPSCoR. And the CHIPS Act is consciously saying, we are going to invest in connecting the entire American economy to the chips and high-tech economy. And I think this is kind of a big deal. Traditionally, up until now, most of the economic benefits that came from our 21st century economy were captured by the big tech hubs, which is fine. I mean, they were doing all the work. But the CHIPS Act said there are innovative people everywhere. There are innovative researchers, innovative companies everywhere. And we have to take steps to attach everywhere to the tech hubs so that everybody benefits. Lastly, the CHIPS Act invests in the weakest part of our innovation chain, which is the link between academia and private enterprise. Coming up with great ideas at universities is a fantastic thing and is very important. CHIPS Act invests in that, but we need to make sure we pull those ideas out of academia and make sure they end up in the rest of society, meaning in companies generating new products, new businesses, entire new industries, and generating jobs. And so the CHIPS Act creates a number of government agencies that are supposed to facilitate that transfer. I'm a little skeptical since the government doesn't actually know how to do that, but there's a lot of money floating around, and so it's hard to imagine it won't do at least some good. Talk a little bit about the CHIPS Act more specifically. As I mentioned, it focuses on 10 specific research areas, mostly technology. This, as I mentioned, is not highly speculative research. The emphasis is on societal impact, which means research that can move from academia to the private sector very quickly. Now, what does all this do? Well, this provides a very powerful political focus for future investments in technology. If you ask the American people, do you support federal spending on basic research? They generally say, yes, that's a good idea. If you then ask them, what do you mean by that? What kind of research do you think this is? And IEEE-USA was actually involved in one of these public opinion polls, and so the data is very robust. So you ask the public, what do you mean by federal research? The public means medical research and technology research, and that's it. They really don't care about the rest of it. The way Congress funded basic research, particularly through the NSF, however, was to just produce a large amount of money and then kind of let the agencies distribute it widely among all the different research areas. What the CHIPS Act does is it creates a tool, the TIPS Directorate, to focus congressional attention to say, hey, if you really want to do more tech research, this is where you should put the money. Politically, that is very, very useful. And we'll talk about why in a minute. But that's really what the TIP Directorate is. It's giving a focus to what IEEE and other engineering groups have been focusing on for quite a long time, the value of technology research to the American economy. Talk a little bit about the workforce investments. Intel, one of Intel's executives gave a very well-noticed speech here in DC a month or so ago, in which he said that industry needs twice as many engineers to make the CHIPS Act work. We have a certain number of engineers in the United States, we're going to need twice as many. I think that's a little bit of an exaggeration, but the point is, yeah, we're going to need a ton of new engineers to build these fabs, to maintain these fabs, and to run these fabs, because fabs take a lot of people, and we don't have a huge number of CHIPS engineers in this country. But that's only part of the workforce. As I mentioned, CHIPS invests in all of them. The goal here is not the research. It's not coming up with clever solutions. It's not solving clever problems. It's about economic growth. And Congress has structured the CHIPS Act specifically to stretch the benefits of chips across the entire society. Excuse me. Oops. which they're doing through broader workforce. What you're seeing here is a map of the EPSCoR states in the United States. They, not too surprising, mostly rural America, mostly the smaller states, states that don't have major national labs, don't have major research universities, maybe have one. But these are states that don't get a lot of federal research grants. And the goal now is to pull federal innovation resources into these states. The theory, as I mentioned, is that there are innovative people in all of these states. There are innovative businesses in these states. But those businesses and people have to be linked into the entire US 21st century technology economy for them to reach their potential. And so that's what the CHIPS Act is going to do. IEEE-USA is working with EPSCoR in Arkansas in the first program to figure out how to do this, which is a workshop that will be held in September. Tech transfer, as I mentioned, so the TIPS Directorate is brand new. It was actually created before the CHIPS Act was passed. Didn't have any money, but they did it anyway. So it's relatively new, but in that relatively brief period of time, they've rolled out a ton of new programs. You can see where some of the innovation, the Regional Innovation Engine awards have gone, which is pretty much everywhere, including places that aren't traditionally seen as tech centers. Other programs include the Partnership for Innovation, which tries to help link academia with entrepreneurs, American Seed Fund, which is supposed to be a government-run incubator, Convergence Accelerator, I-Core, which has been around a while, but it got moved to TIPS and given a bunch of new money. Those are just a few of the programs that the government is standing up to try to bridge the gap between academia and the private sector. Now, my sense is all of these are going to fail unless they have strong input from actual practitioners. In other words, the government can't move ideas from academia into the private sector. It doesn't know how, and it's not going to know how. What it needs are people in the real world who do know how to make that happen to actually work with the government to make these programs work. So far, TIP has been reasonably good at reaching out to the private sector and has been reasonably good about creating opportunities for regular people, entrepreneurs, technologists, engineers, CEOs, to work with them. But more work needs to be done before this is going to work. So a piece of the CHIPS Act, actually several pieces, is dedicated towards small businesses, saying most of the money is going to go to the big businesses. They're the ones building the fabs. That's all fine. But some of the money needs to go to small businesses and smaller universities. Most federal research grants go to the major tier 1 research schools, which is fine. They do great work and they're very important. CHIPS Act dedicates a certain amount of money to go to smaller universities and smaller researchers to make sure that their good ideas get a chance as well. Commerce Department has rules in place for the fabs and for their regional tech hubs that favor partnerships between large and small businesses. In other words, when companies apply to get CHIPS money from the Commerce Department, and most of the money is flowing through Commerce, the companies have to say how they're going to work with small businesses in the regions that they're building in. So Intel is building a facility in Central Ohio. They have to have a plan for working with companies in Central Ohio, smaller businesses in Central Ohio. There's also going to be supply chain funds and some other funds dedicated to smaller companies. Just the other day, NIST came out with a plan for working on supply chain issues with the big companies, which had this terribly helpful line, dedicated funding opportunities for smaller projects is coming later in 2023. So I have no idea what those are yet, but they will be there and there will be money behind them. Everybody knows that the supply chain is not just the big companies. The small companies have a vital role to play too and need to not be locked out of whatever the big companies do. Commerce recognizes that, NIST specifically in this case, but there's still more work to be done. Additionally, there are programs that are specific to rural America, minority-owned firms, and small businesses. That is in the CHIPS Act, but also the Inflation Reduction Act, which passed shortly after CHIPS, which, interestingly enough, has nothing to do with inflation and is really just a global warming and innovation bill, which is fine because we like that. So what is the consequences of all this? What do we expect to see? Well, I think it's, with the amount of money that they're spending, it's going to be very difficult not to see broader and faster innovation across the US economy, not just in chips. A lot of the money, chip manufacturing incorporates a lot of other fields, so they'll benefit. But the bill is much broader than just manufacturing chips. And so additional research areas, the TIP directorate, the additional programs should increase innovation across dozens and dozens of fields and the entire country, which is exciting. I suspect the bill will result in public buy-in, better public buy-in for tech and technology investments. Public was broadly supportive of our work anyway. But when you start building fabs in rural America outside of the tech hubs, rural America starts to notice that the innovation economy is not just about tech guys in Silicon Valley, it's about everybody. IEEE-USA has been involved in a program for about 4 years now to teach non-technical Americans why technology and technology innovations and research are important to them. For example, we had a project up in Maine where we went and said, okay, why would regular people in Maine care about investments in STEM? Well, because the Bath Iron Works requires technology, because the University of Maine is a very good industrial engineering university, and because Maine has a lot of agriculture, blueberries, lobsters, trees, that are high tech. All of those ag fields are very high tech. And so we went to the general public and said, this is how your state benefits from these investments. Well, the CHIPS Act makes that much easier. There's a $100 billion Micron plant going in outside of Syracuse, New York, which is where I happen to be from. That part of upstate New York has been in economic decline since before I was born. And it's hard to put $100 billion into an area like that without having a really big impact, which will tend to make people very happy with you. So we think in general, public support of tech and technologists will go up. I think the American workforce will be strengthened. The bill will invest in skills across the economy, both in terms of educational attainment and geography. I think the bill will help teach industry how to work with academia and help teach academia how to work with industry. Again, you can't spend this kind of money without some of this working. And building ties between academia and industry, small businesses in rural America, smaller universities, and ties between small universities and big universities is certainly a good thing. And I do think it will tie rural America more closely to the tech hubs, bringing economic benefits to both. And I really think in the long run, if we can do that, that will be the biggest long-term impact from the CHIPS Act on the American economy. So that's all well and good, but let's talk some political realities here. None of this is paid for. That's not true. The $52 billion to build fabs is paid for. That's paid for the next 5 years, and Congress doesn't need to touch it. Nothing else is paid for through 2023. So it's in the 2023 budget. It is not in the 2024 budget. IEEE-USA's top legislative priority this year is to get funding for the TIPS Directorate and all the other non-chip manufacturing portions of the CHIPS Act, which we're going to have to do every year. The problem is the United States is running a $1.6 trillion deficit, and it is estimated the deficit will be $2 trillion next year, although the recent debt ceiling negotiation might start to rein that in. Deficits cause inflation. Inflation is one of the most politically dangerous phenomena in society. It's probably even more dangerous than unemployment if you are an elected official. People who lose their jobs, of course, care deeply about unemployment, But people who don't lose their jobs, it's theoretical, but everybody feels inflation. The point here is that there's a lot less interest from Congress in 2024 for bright, new, shiny programs like the CHIPS Act than there was in 2023. So the fight to get increased funding for the programs in CHIPS is hard, and I suspect it will get harder. Friend of mine, Guru Matavan, IEEE member, IEEE student member I had the privilege of working with, is currently the youngest director at the National Academy of Engineering. He penned an article a couple months ago, which he called the Grind Challenge, which I thought was brilliant. What Guru said was, it is easier to build a big flashy thing than it is to maintain a big flashy thing. In other words, if you're a politician and you secure funding to build a bridge that brings economic benefit to your city, that is fantastic, and the public will love you for it, and you can get paid on that for the next 10 years. If you are the legislator that got an increase in funding for maintenance of the bridge once it has already been built, nobody cares, because the public just assumes that the bridge will be taken care of. This is kind of the problem we have with the CHIPS Act. Congress voted for the CHIPS Act, and they all went home and bragged about passing it, which they should, because it's a good bill. Now they have to maintain it, and there's a lot less political payoff for maintaining a program, a lot less than there is than when you created originally. The point of this is that maintaining the momentum of the CHIPS Act, manufacturing is all set, but maintaining everything else is in fact going to be a very substantial political fight. And then there's this. The EU has its own CHIPS Act, which will invest between 20 and 35 billion in chips manufacturing by 2030. France is putting up another 1.9 billion, and Germany is putting up another 12 billion. Korea plans on investing between 50 and 65 billion in chip manufacturing. China has said it will invest 150 billion in chips. Though you always got to be a little skeptical about China. Japan, India, Taiwan, many other countries either have programs or are developing programs in direct response to the American CHIPS Act. Truth of the matter is that part of the reason the CHIPS Act passed was as a response to China. The United States Congress wanted to make sure critical technologies were manufactured here, not there, but every other country in the world got caught in the crossfire. Particularly Japan, Korea, and most importantly, Taiwan. So we need to consider what the CHIPS Act does in a global context. We are, for the past 30 years, the prevailing mindset among decision makers, mostly around the world, was globalization. We want to tie the world together, tie our economies together, which will generate economic benefit for everyone. The CHIPS Act is a fairly clear repudiation of that. Not entirely, but at least in some way, to say, no, the United States is not going to tie ourselves to the rest of the world. We're going to do it here. Congress is dumping a really large amount of money into making sure that happens, and now we're seeing other countries doing it as well. The consequence of this in the past has been a glut of chips, not soon, because it takes a while. But not all of these countries can win. Not all of these bets can pay off. And the competition between countries to succeed is likely to be unpleasant for many people. Currently, I would bet on China losing a lot of that, but you never know. So the bottom line in all this is that CHIPS is a massive global shift in government priorities, away from globalization and general research to focused industrial policy designed to strengthen parts of the economy that the United States government considers to be important. While the bill itself is only temporary, you got 5 years, after which most of these incentives will disappear, but it should have a lasting impact on the technology workforce and on the US economy. It should leave the United States better off. Although there's a lot of ifs, there's a lot of programs that still need to be developed and a lot of questions that still need to be answered. IEEE-USA played a role that we're very proud of in getting the CHIPS Act passed. It was actually an IEEE-USA fellow on Capitol Hill that wrote the very first memo describing to Senator Schumer what the CHIPS Act might look like. It was called the Endless Frontier Act back then. Now we, as engineers, need to play a role in making sure this thing works. We need to make sure that politicians understand what these programs are and why they're beneficial. And we need to make sure the public understands that these investments are not shoveling money into rich people's pockets, but making very real investments in America and the American economy that should pay off for everybody. I am again with IEEE-USA. There's all our links if you're interested, particularly our YouTube channel, which should have a link to this presentation before too long. I'm Russ Harrison. I'm the managing director of IEEE-USA. I've been the managing director now for a year. I was director of government relations for about 8 years before that. It is an honor and privilege to work with engineers in the United States, and it has been an honor to work with AABEA for the past year or so since we were first introduced, and I look forward to finding ways to continue to do that. With that, I'm going to stop sharing. And a number of you, oops, apparently, there we go, had asked questions.
Wow. Thank you, Russ. Yeah, absolutely. Thank you for the wonderful presentation. Especially, this is the area that, as you said, we need to be more cognizant. Working with the lawmakers, IEEE is very diligent, and I, as a member of now what they call is Optica, what is used to be the Optical Society of America and SPIE, I had the privilege to go along with IEEE to the Capitol Hill a number of years for a program called CVD, or Congressional Visiting Day. So one of the things we have been thinking, and we are trying, that can AABEA become a part of the annual event to go to the Congress with IEEE and of course with Optica, if we get to do it together again, if not maybe just with only with the IEEE, and that has to be a commitment both from IEEE as well as from AABEA. This year IEEE invited us. We all thought we were going to go, and then it didn't work out that way. So
this year was a difficult year because of COVID. We couldn't really properly plan. We didn't know if we were going to be able to do it, so we kind of threw it together at the last minute. But IEEE-USA is going to do another CVD next year, and AABEA will be invited to join us. I don't know about the other societies. We certainly would like to work with Optica, the mechanical engineers, the civil engineers. Civil engineers really does their own event, but you know, the other engineering societies, and would love to have you all join us one way or another.
Right. Optica actually did it this year on their own, a small one, but still 2 days. So I think they might come together next year with IEEE, but let's, so that's something on our agenda. It should be, and Ruhul, you should keep a note of this thing, that next year, our DC chapter, but from all chapters, we will invite representative from Michigan, New England, South California, Silicon Valley, everywhere, you know, wherever we have AABEA chapter, Arizona, Texas, Florida, probably going to have Atlanta, Georgia is going to have. So please make it a note so that we can, you know, it's going to be in April, I suppose, right?
I'm sorry, say that again?
Is it going to be in April next year? Which month? Or is it March?
Probably will be in March.
March, okay.
Probably the end of March. But it will depend when Easter is, and I haven't looked, because the Congress takes the week of Easter off.
Right.
So we need to move around that.
All right. So let's plan on that. Ruhul and I will, you know, take the main initiative.
We will set, I'm hoping we'll set the date by Labor Day so that everybody has enough time and we'll all know. And as soon as we know, I will loop you guys in because we'd love to have you join us.
Yeah, absolutely. So let's see from question. Let's take some questions from the audience, and I'm sure many of them have quite a few questions. Maybe it's better that I call each of you so that we don't get into a different kind of thing. So Dr. Gulshanara, if you would like to ask any questions, please go ahead. You are muted, please unmute.
Thank you so much for this informative. It's extremely wide range of areas that you talked, and it takes, since I'm not really from this area of research, it will take me some time to absorb and try to understand. But still, about the CHIP Act, I think I understand that one of the main issues should be to make more chips inside United States so that we are not dependent on other countries. And for that, all the options that should be on the plate, like silicon is of course, and of course the question that I raised right in the very beginning, that carbon, since we are really working on carbon capture technology, so that would serve two purposes. One, the carbon capture technology will be expedited, and they will be working hand to hand with the chip manufacturing using carbon. So that would really be very, I think would be very helpful for the economy and for research purposes. So that was my question.
And I think that the CHIPS Act, that type of research is precisely the type of thing the CHIPS Act is supposed to be focusing on. It's speculative, it's basic research. We don't know how to do this. This isn't fine-tuning a product, but it's research that has very direct, very immediate impact on the country. The CHIPS Act itself, looking at the CHIPS part, the $52 billion, there was some debate in Congress about what that should pay for. Pardon me. Whether it should go for just the fab, whether it's the pre-silicon, the design, the packaging, all the other pieces of the design process. And what Congress ultimately decided, and this is one of the things that we talked about at our CVD, was to make it broad. Last year's CVD, not this year's CVD. Last year's CVD was virtual. It wasn't nearly as much fun, but it was effective. So talking about the entire chain, and you're right that the purpose of the CHIPS Act, purpose of the first half of the CHIPS Act, is to bake chips, broadly defined with investments wherever it is that the market needs investments. It's a very broadly written bill, and the government is interpreting it broadly to fund whatever. But I think from a research standpoint, the TIP Directorate, I mean, what you're working on hits several of their categories, and is certainly the kind of research that they should be looking at.
Thank you.
Welcome.
Wonderful. So let's take another question. Mohammed Iqbal, do you have any questions?
Yeah, I have a question. The way I heard the presentation seems to me that the CHIP Act, the $52 billion is like a done deal, and going forward would be the activity. Is it something like that, or I misunderstood?
Okay, so before the government can spend money, two things have to happen. Congress has to authorize the spending, and they have to appropriate the money. And think about it this way. Imagine you are 14 years old and you want to go to the movies. You have to do two things. You have to ask your mom and dad for permission to go to the movies. That's authorizing. Then you have to ask them for $20 for the ticket. That's appropriating.
Okay.
So the CHIPS Act, normally in Congress, those are two different bills done by two different committees at two different times. And so they're two entirely different processes. The CHIPS Act was actually very unusual in that the $52 billion, the CHIPS part, was both an authorization bill and an appropriation bill. And it appropriated the money for 5 years. What it actually said was, if Congress fails to appropriate this much money each of the next 5 years, it is deemed to have appropriated that much money. So Congress can do more, but they can't do less. Everything else in the bill, all the research, all the workforce, all the tech transfer, all of that was authorized for 5 years, but it was only appropriated for 1 year in the appropriations bill last year. So this year they have to do another appropriations bill. We have to make sure it's in there. We have to make sure it doesn't get cut. The problem is research is a very easy budget for politicians to cut. Because if you cut, let's say the government eliminated all research spending in the 2024 budget, well, there's not actually much of an impact on the United States in the first year. Now, in the 10th year, it would be devastating. But most politicians don't think that far ahead. So we're going to have to fight to make sure the funds that we got in 2023 are also available in 2024 and hopefully get a little bit of extra money. Early signs from Congress are promising, but we got a long way to go before they finish the appropriation bills, so we got to stay on it. But that's the deal. It's the authorization and the appropriation. We got one, but we still got to get the other one.
Okay, very, very good. As a matter of fact, your presentation is fantastic because I was not aware of that is happening in this manner, and there are 10 different areas they're touching. Those are extremely needed. And my two questions, one is followed by the other one. My second question is, AABEA looked like in the presentation you mentioned, and I'm pretty much sure that is more or less influenced, or they are getting more supported by the government to start, right? Is it
sorry, I heard your question except the most important word. Is who being supported by government?
The SBS, Small Business Administration, are they okay?
SBIA.
Are they more into that, or like big companies, Intel, they are easy to get and they already
most of the CHIPS money is going to go to the big companies, because the 52 billion, most of that is going to big companies because small companies can't build a fab. But there are portions of it that need to go to companies where these fabs are being built. The idea is the fabs are supposed to raise up the entire region, not just the company. And so most of that money will go to smaller companies. There are additional programs in the CHIPS Act dedicated to small and disadvantaged companies. There's not much in the CHIPS Act for SBIRs or SBA, but there are, in other bills last year, there was, particularly the Inflation Reduction Act, which did have more money for small businesses. So the CHIPS Act doesn't invest in SBIRs all that much, although some of the money is going to flow to small business research. It doesn't matter. That's the way the law works. So that the budgets will end up going up.
How in that case, like, when I was with Intel, I was the program manager. At that time, Gary Barrett was the CEO. They invested $3 billion in China to build a fab. And now we get money and they might invest using their, other countries. How that help a small company who can do many AI things, many small chip design to help the community, as well as that community means world. And
so part of the
money
logic
over here, but could be
entire
world. Go ahead. Entire world can get benefit. So go ahead.
How that gonna be controlled? Yeah. Yep. Part of the logic of the CHIPS Act was, if we're manufacturing chips in China, small businesses in the United States can't even compete because it's not here. A lot of the small business contracts are for companies that are there. And if the manufacturing is in China or some other country, small businesses in China and other countries are going to get the contracts. The theory is, if we build the fab in the United States, they will source from, not exclusively, but it'll be easier for small businesses to get contracts with them. One of the big programs that CHIPS sets up is the regional technology engines. These are consortia of groups in parts of the country that don't do a lot of innovating. Again, it's not Boston, Austin, and Silicon Valley, it's everywhere else. But these engines are designed to pull together the resources of a given area to generate the critical mass you need to start building up your indigenous tech companies. And part of those engines has to be small businesses. They have to be included in the planning. They have to be part of the beneficiaries, and they have to be part of the region, along with universities, smaller schools, community colleges, civic groups, local state governments. The bill is very clear. If you want to get this investment money, you got to get everybody around a table to come up with a plan that benefits everybody. The first reach, I mean, it's early still. It's hard to say if it's going to work or not, but the early returns are, the plans look decent. I mean, they are, big companies are in fact pulling small companies to the table and saying, what do you need? How can we work with you? What do we need to do? And it looks like it's working. So fingers crossed, but I think the CHIPS Act will have a pretty big impact on small business in this country.
Okay, very good. Thanks. Thanks.
Okay, so let's take another question from New England. Tanvir Nawaz is here. Tanvir, do you have any question? Please go ahead.
Hi, yes, thanks, speaker, the keynote speaker, for giving your time. I have one question. I mean, in general, chip industry is pretty broad, and I remember in 1980s when US did the Sematech consortium to tackle the Japan threat, and my understanding is this is mainly focused on creating the China thread. And I mean, Sematech is pretty much ineffective right now. And my concern is whether we are addressing the root cause of why and what it is that we're trying to solve, rather than repeating the Sematech thing, because a lot of aspects of chip designs, like design area, US has approximately 90% market share. In EDA, electronic design automation, they have pretty much 100%, and core IP also 100% market share. Only place that US is vulnerable is foundries, which US probably has about 29% of market shares. So are we giving basically subsidies to companies to build here? And how is it going to be sustainable, provided that South Korea is also having similar act in their, I think, $65 billion, much bigger than $52 billion that we are doing. And similarly, Europe also have their own chip act. And so is it a competition of subsidies, and how is it going to be sustainable? Thank you.
Yeah, that's kind of the, well, it's $100 billion, $200 billion question. Because you're right, the 52 billion, the CHIPS Act, part of the CHIPS Act, is just subsidies. We are going to pay companies to build fabs in the United States. It's not a terribly sophisticated idea, not a bad idea, but it's not very complicated. And you are correct. Korea is responding by doing the same thing. Europe is responding by doing the same thing. China is responding. I imagine Taiwan is going to respond. And that is the question, you know, if business decisions are being made solely by how much tax dollars you can get to build your fab in a country, that's not sustainable in the long run. And the CHIPS Act isn't sustainable. It's not designed to be. It's a 5-year program. It is supposed to get the fabs up and running, and then the government's going to step away and say, okay, you got to run this on your own now. Well, is that going to work? What happens if, you know, Korea doesn't back away? What happens if Europe doesn't back away? I'm not sure Europe's going to get this right anyway, but certainly Taiwan and Korea and Japan could. And that's the question. I mean, we spend 20 billion taxpayer dollars to build a $100 billion fab outside of Syracuse. It gets built, the government backs away, Korea doesn't. Does Taiwan, does Intel or Micron rather, then start shifting work to Korea to take advantage of tax breaks there? The theory is these fabs are so big, so expensive, and take so long to build that companies won't be able to move very quickly. I guess we'll see. But yeah, I think you have identified a challenge, and it is a weakness, and it's, you know, global competition is difficult. And it's not clear to me who's going to win, but it is clear to me that the government can't spend this kind of money in the United States without having some positive impact. Whether it is as impactful as we hope or not remains to be seen, but I do think it will be at least somewhat positive in the long run.
Okay, I hope Tanvir initiated at least a really intelligent challenge and intelligent question. Let's go to Shah Raja. I can see him. I cannot see him, but Raja, you have any question? Please unmute yourself and open your camera if you can. Oh. All right. So while he's probably taking a break or something, Rashid joined. I cannot see him either. His camera is off. You have any question? All right, Rashid is quiet too. So Ruhul, you might wanna be the next to ask a question.
Sure. Thank you, Mr. Harrison, for that very informative presentation. So I understand that the CHIPS Act is a 5-year program, and it's designed to be a temporary program where after 5 years, it would just kind of go away. But the question I kind of had in my mind lingering is, and you kind of already answered it, where, you know, the hope is once an awardee gets the funding, these are going to be like huge chip plants, you know, huge facilities that they can't just, you know, like, you know, a big corporation just decide next day just to turn off the lights and just shut down this huge plant and just go somewhere cheaper where the labor is cheaper and there's better incentives, whatnot. But I wonder if there's any kind of requirement, you know, within this legislation that when an awardee gets the funding, that there's a minimum obligation as far as the length of time that these awardees have to keep their doors open and be operational, you know, on the soil of this country. Is there any kind of requirement like that, as you know of?
Not that I'm aware of. However, as Anis mentioned earlier, as we were getting started, the incentives that some of these fabs are getting goes beyond just the CHIPS Act. New York State has chipped in some tax incentives for Micron. Those usually come with those kind of qualifications. You know, you don't have to pay taxes for the next 5 years as long as you continue to operate in the United States for the next, or in New York State, for the next 8 years. And if you don't, then you have to pay back a percentage of the taxes. It gets complicated. The problem is those are very, very difficult to enforce because, you know, Intel's building a $100 billion plant in Ohio. CHIPS Act goes for 5 years. If Intel is required to operate that fab for 10 years, well, you know, it's going to take 3 years to build the thing. So now it's 7 years. And they're going to operate it. Is it going to be operating at 100%? You know, even if they spend 3 years building it, they spend 2 years operating it. So now we're halfway, 5 years. Then Intel decides to shut the thing down. Well, they're not going to shut it down the first day. It's going to kind of taper off over time. And all they got to do is make sure that that time takes 5 years. So the incentives don't work very well, or the time restrictions tend not to work very well. But the expectation is the mere size of these things is going to make them permanent. And to a certain extent, it probably will. Whether that is 10 years or 30 years, I don't know, probably not 30. But that's the plan. We'll have to see, and which is, I think, why all the other investments are also important. Because, you know, in the long run, over the next 50 years, these fabs are going to end up wherever it makes economic sense. And in the long run, if it's cheaper and better to build in Korea, that's where they'll eventually end up. The United States has to get more competitive at the same time we're investing money. And if we don't, the plants will leave. But the investments in the workforce, the investments in research, the investments in infrastructure will stay either way.
Right. And just to kind of add another comment, you know, like it's a good idea that this legislation includes additional funding in the development of workforce, because when you develop more capable people in order to participate in this new, economy, it will actually help the U.S. compete with other high-value workers in other countries. And so the competition as far as wages is less, because these are high-value workers, and they have more skills, and there's high-valued workers with a higher skill set tend to have less competition with wages, in other countries. So that kind of helps keep this investment in this country, I think.
Yeah, the United States does not want to compete on wages, because you cannot be rich and cheap at the same time. So we want to be a high wage country, but you can only be a high wage country if you are also a high skill country. And so you're right. The way we elevate the overall prosperity level of the United States is by elevating the overall skill level in the United States. And that's what the CHIPS Act is trying to do. Ruhul, you had also asked earlier about shortages. There are portions of the CHIPS Act that deal with shortages. I mentioned one of them in small business. There's not a lot in there on shortages, because there were other bills that dealt specifically with chip shortages and technology shortages in general. And I think there was the Infrastructure Act bill, and then the Inflation Reduction Act. And I forget which one of them had the shortage language in it, but it set up a new, working group within the government to track product shortages, to track bottlenecks, and to start to develop the resources to help identify shortages before they become critical. So the government is doing a lot in that space. It's mostly not within the context of the CHIPS Act, but it is still happening.
Wonderful. So let's go to, I see from New York, is that Dipti Barua? If you are there, please ask if you have any question. The 646 number. I don't know who that is, but anyway, we're moving forward. Farooq Siddiqui Bhai, you are a civil engineer, but please ask any question you may have.
Well, that's one of the things, as my question had already been answered. I was going to ask, how is the appropriations going to work? Because I know there is a House Appropriations Committee, and that it's a big hurdle to cross every year. So,
yep.
Since it has been answered, I don't have any questions.
We are going to
answer now.
We are going to get the appropriations bills passed by going up to Capitol Hill and talking to everybody about all of this, to make sure they understand what the CHIPS Act is, make sure they understand what chips are, make sure they understand how all of this helps their community. This is actually one of the it's one of the reasons IEEE-USA's first CHIPS Act event will be in Arkansas, because Arkansas has two appropriators, members of Congress on the Appropriations Committee, and Arkansas citizens wouldn't necessarily see the connection between the CHIPS Act and them. So we want to make sure they see it. And that's how we're going to win. We're going to make sure everybody knows what this means to every American citizen.
But this has to be done the next 4 years.
Yep. I see it as job security.
I see. Okay. All right.
Arkansas has a lot of other activities going on. Maybe Russ and I will talk to someone over there over another Zoom meeting. Now we come to Dr. Sufyan Khandekar Bhai. Please, if you have any comment and questions, please go ahead.
Thank you, Anis. I'd like to congratulate the keynote presenter, Mr. Russell Harrison. That was wonderful. I learned quite a bit, not being from that. Few things I know, I understood, and it got cleared up in the presentation that that this CHIPS Act has been sold as a big event, but what we see when you go into the depth of this one, this is a very short-term kind of an incentive which may or may not work. And the amount of money is being allocated, yeah, it looks big, 52 billion, but when a single fab costs more than $100 billion, that is a small fraction. And obviously, the government is not going to invest 52 in one fab. Currently, if I understand correctly, that there is a big fab in Taiwan, and there is none in the United States. I don't know any other places. So Taiwan is in a driver's seat, number one. The supply line is controlled by China. And this was a wake-up call, if I think, for United States. Somehow they realized that that is a dangerous situation. Let's do something. It is kind of doing something, but it is not a full-fledged. As we have already learned that, say Intel is investing $100 billion, they can call it a day after 5 years. So what happens? There is no requirement for that. The other things also this act talks about is participation of SBE, small business enterprises. Now, this is our experience. I'm in the field for a long time. We have to deal with SBE. Most of the federal funded project we do, there is a mandatory requirement to set aside 17% of the total construction cost to SBE. Voluntarily, it doesn't work. If it is made mandatory, because anything you do, whether it's a fab, there is a big portion is going to be the construction cost. So unless you set aside a mandatory amount from the grant, it is not going to be beneficial to the small business enterprise. It has to be mandatory, not voluntary. The other question I had that this is a curiosity because I'm very much involved with ASC, American Society of Civil Engineers. I know they are very active on the infrastructure bill. They had a liaison, they participate, all those things. Is there any cooperation between ASC and IEEE? So that's my last question. Thank you.
Yeah, there were some big questions in there. Your basic assessment of both the global competition and small businesses is correct. It's difficult to do. Working with SBEs are difficult. That is why most government programs, a certain percentage of the money needs to go to small businesses and minority businesses, women-owned businesses.
Yeah,
those programs sometimes work and sometimes don't. It's kind of a crude tool, but it is better than nothing. I do prefer the CHIPS Act approach of coming up with a regional plan and requiring small businesses to be part of the planning team to get them in on the ground floor so they can find a space. But it is a challenge. IEEE-USA does work closely with the other engineering associations. We work with ASME all the time. They're right down the mechanical engineers. We work with Optica. Well, I should say we used to work with them all the time. COVID messed things up and we've kind of all lost track of each other. But I have an invitation actually from Saifer Rahman, the IEEE president, to the engineering societies asking for a summit meeting in the end of August to talk about joint projects that we can do to kind of jumpstart that partnership and those relationships that have kind of faded over the last couple of years. But yeah, the ASME's office is in the same building that IEEE-USA used to be in. Now we're a block away. Optica is about a 6-minute walk from our office. They have a very nice building up by DuPont Circle. The civil engineers, it's a little bit different because their priorities are a little bit different. As you said, their priority was the infrastructure bill, which it should have been. And we helped them on that. But our priority was the CHIPS Act, which is not their priority. they're involved, but not nearly as much. So we work with them, but their concerns are slightly different. So not quite as closely as the mechanicals.
One of the kind of flow of Dr. Khandakar's question is, to many, it looks like the CHIPS Act is a little bit too little, too late kind of situation. And the reason is that as your presentation outlined, Korea and China is allocating $109 or so billion over next 10 years. But whether we are suspicious of many of the things, but nonetheless, they are flooding the chip market, the cheaper ones, the simple ones, by their own technology. So one of the thing I have been discussing with whoever I can is the product-oriented outlook. In the United States, we allocate a lot of money, always in the billion. I haven't heard anything less than billion, and that doesn't mean that the small businesses are getting all of those unless they're lucky. The other thing is, it's so much goes around the management, around the logistics, and all of those things. And in my estimate, there could be more effective way of managing or allocating the money towards the product. Like you mentioned in your presentation, that this is not an aesthetic research kind of outlook. This is for perfecting or producing the products. Now, the products in a fab, which are the chips, and we all know that have cost a lot of money, but there are other products, supply chain in the fab. For example, silicon wafer, a benign silicon wafer. There is only 6 or 7 companies worldwide. They are making their silicon wafer, their Czochralski technique going on for ages, and they don't change anything. And there's no opportunity for smaller companies to participate in there either, because they are so close to. Nonetheless, the United States have active policy of bringing a lot of other small countries into the supply chain so that pressure on China can be minimized or reduced at least. Vietnam is an example. Malaysia started doing, but they're not doing much right now. They are so much dependent on SK Hynix and that kind of Chinese and Korean company, and probably Taiwanese. So the Taiwan is the biggest chip manufacturer, but they are, of course, they don't manufacture their own product, they manufacture for others. That is the fabless model Maurice Chang implemented at TSMC. So then what it boils down to, that in America, in the United States, we have many opportunities that we are not harnessing. These low-hanging fruits, more investment, product-oriented, directly product-oriented. And that product may or may not be the finished product. It can be even making the silicon wafers or processing the silicon wafers or a part of the overall fab. That can be done much, much easily. And the CHIPS Act, I couldn't agree more with Russ that we should go to the Congress and make the lawmakers understand that how do they appropriate and allocate the funds is very important. It's not just the overall $52 billion, we have allocated it, okay, let's see what happens. No, it's not, that's not enough. They also need to understand the priorities a little better, not from the big companies, not from the point of view of Intel and Samsung and Motorola and Texas Instruments, but also from the whole supply chain. A fab has a long supply chain. And for example, polysilicon that goes into making the silicon wafer, 80–85% of that comes from China. That can be done easily over here or somewhere else, like in Bangladesh. Bangladesh has a lot of quality sand. The processing plant cost about $20 or so million. We have did the calculation. over 6 years. And even if you are making, let's say, only $10 per wafer and you're producing 10 million wafer a year, it's a reasonable amount of business. But there is no initiative, no chance, no opportunity to take that kind of steps. Not even in here in the United States, let's say there are a lot of quality standards over here, or even we bring the polysilicon and want to make the wafers over here, it costs only $6 or so million to buy 2 machines for 8-inch, one 8-inch, one 12-inch wafer making machine. And that in 72 hours, that can make 2-meter ingot. So that means 2,000 wafer, etc. That economics is so useful, but it's not part of the CHIPS Act. So I think we got to go to the Congress and make them understand these are the low-hanging fruits that we are missing.
Yeah. I think the fundamental problem is that members of Congress do not understand how chips are manufactured. And frankly, they're not going to. And it's going to take people who do understand going in and saying, this is good, but this is what's really happening. This is how it works, to help them understand. I mean, they're not they're not engineers. There are a few engineers in there, but they're not chips engineers. And so somebody needs to explain it to them, and it's who better than us?
Sure, absolutely. Mohammed, I would like to talk to you and work with you. Please share your email with me sometime when you can. Anyone else has any other question for us, please? You muted.
Okay, now I have a question, additional question, which Anis by what you just said exactly. How can this appropriation committee can fund to the small companies who can benefit directly? I mean, chip, in my opinion, because I'm in that field, chip doesn't mean just basically making just the wafer or just the chip. It could be anything related to the circuit board, to PCB, there are so many. They don't get fund finally, and then slowly goes to the big company, and big company goes to the other country, which is fine for the economic reason, like Russ said. It always has to be economic reason wherever they get the most benefit. But the small company over here can get 1,000 times benefited. And how to approach, because these people who are dealing with, they are not technical people. They are not necessarily understand what is chip means to them. So as a big job, but can I ask you another question that is related to this? They said next year there's a meeting in Arkansas, and there are 2 appropriation committee members going to be there. Can you elaborate that part? I'm not understanding that part.
Well,
what's going to happen?
So it's a little more subtle than that. So the state of Arkansas elects 2 members of Congress who sit on the Appropriations Committee, one in the House and one in the Senate. So they are going to have a disproportionate say in what the government spends money on, well, every year.
Russ, is Tim Cotton one of them?
See, I knew you were going to ask that. I forget which one it was. The appropriators. It's Steve Womack.
Oh.
And Bozeman, I believe.
Oh,
Yeah, and Bozeman, Senator Bozeman. Now, Cotton is on the defense. He's on armed services, judiciary, and intelligence, which is not too surprising. So the idea is we're going to hold this event in Arkansas, not to talk directly to the legislators, although we've invited them to attend, but to talk to their voters and to tell the citizens of Arkansas, funding the CHIPS Act is important to you because all of these great things are happening in your state because of that. The theory is if the voters think it's important, then the legislators will also think it's important. Because while legislators want to do what's in the best interest of the country, they really want to keep their jobs. And so if we communicate directly with the public, that's a better way of getting through to them. Also, the event we're holding in Arkansas is focused primarily on industry. There are academic components, but we have representatives from a bunch of different businesses that are going to be speaking, and even more businesses that will be there. those guys talk to the members of Congress all the time. And so if those people say, you know, most of the companies in Arkansas are small. Say, I have a small company. There is, in fact, a chip design company, a packaging company called Ozark Technologies in Arkansas. And if they go to Womack and say, Congressman Womack, I help design chips in Arkansas, and the CHIPS Act is good for me in Arkansas and the 55 people I employ in Arkansas, that sort of message resonates really loudly. So that's the political approach. Now, I've been asked twice now how small businesses can get access to CHIPS money. And it is unlikely that a small business is going to be able to apply directly for CHIPS money from the government, simply because small companies can't take that much money. And the government, as Anise pointed out, likes to deal in big numbers because it's easier. Instead, what is more likely to happen is the big companies will get big chunks of money with a condition that a certain percent of it be spent on small businesses. And so the small businesses will go to Intel for partnerships, or Micron, or whoever else they're partnering with. So it's going to come through the business, through the companies, not through the government, which frankly is a lot easier because there's an awful lot of paperwork when you're dealing with the government, and small businesses have a tough time with that. But that's the theory.
Yeah, makes sense. Thank you.
You're welcome.
Wonderful. So Russ, I would like to connect with you again regarding Arkansas. I have a particular interest. I'm an adjunct professor at Fayetteville University, Arkansas. So I go there a lot of times, and you know, Walmart has a lot of efforts there too. So if we can connect, and I know people who knows people in that hierarchy. So maybe we can connect somehow and make a point there.
I would love to do that. We've already reached out to Arkansas, reached out to Walmart. We're hoping that they will do some talk on logistics technology, which they're of course very good at. And frankly, Arkansas is very good at. Let me reshare my screen for a second. I just wanted to put my email and phone number back up on the screen for everybody. If any of you have additional questions or want additional conversations, please reach out anytime. Rahul, I'd like to talk to you about the USDA because we want to get them involved in the Arkansas meeting, and I haven't been able to break through yet. So I'd love to talk to you. I'll try to send you an email tomorrow.
Okay, Russ, I also have a question that I will send you an email, then I will like to know about this Arkansas, that what time and this and that. So I will do that.
I think on behalf of AABEA, we can centralize it. So
okay.
If you send it to me or Ruhul is the
yeah, I will say, Anis, I'm going to send it to
sure.
you. Okay,
but by all means, please do, because more of us show is better. More
excellent.
Is
I appreciate the help. Thank you.
Thank you. Appreciate that.
Anis, just a quick question.
Yeah, please.
From the Arkansas University, he's a professor there in physics, right?
He is in Pine Bluff.
Oh, Pine Bluff.
Yeah.
How far is that? Far away?
Pine Bluff is towards river Mississippi. It's close to Little Rock, and Fayetteville is on all the way on the west side of the state.
Okay.
That's where the Walmart headquarters is, in Fayetteville.
Okay. If nothing works, at least we will shop in the Walmart. All right.
Excellent food in Arkansas. Excellent barbecue in Little Rock.
Thank you very much.
Yeah, that's true. Wow, overall, Arkansas has a lot of good things. I'm very positive about their food and everything. It's really a nice state. So,
Denise, I will reach out to you. I'd love to chat with you about your contacts and thoughts.
Yeah. I would love to organize another Zoom meeting for that purpose.
Wonderful.
And Mohammed, you are welcome to join, and Rahul will join.
Sure. Thank you for that. I will be in touch with you.
Absolutely.
Okay.
All right, then let's come to an end today. It has been a wonderful webinar. Thank you, Russell. We can thank you enough for taking the time in your busy schedule and participating here. We hope to hear from you soon again. And Professor Rahman is on his, Professor Saifur Rahman, who is now the president of the IEEE, whole IEEE, not just the United States. He is on his 5-country, 6-city tour for a month. He's on his way to Hong Kong, then he will be in Dhaka and everything. So once he comes back, I hope Russ and I can again arrange another thing with him, with
Wonderful.
Professor Saifur Rahman.
Anis, thank you for putting this together and thank you for all the work you did. I appreciate your leadership and it's an honor to be included. Thank you.
Absolutely. It's our pleasure is all ours. So with that,
Thank you.
bye-bye, everybody. Have a
Good
good
afternoon, everyone.
Talk
Thank
to you
you.
all soon
Thank
again.
you.
Okay.
Thank you.